Good morning, everyone. It's Kuku here from the SIMM, and would like to take this opportunity to welcome all of you to the webinar this morning. And we thank you for taking the time to join us today, and I'm sure that you will find the presentation to be of great value and benefit to you. And without taking any more time, I'm just going to hand over to Chris, and Chris will introduce himself to you, and then he will take over and start with his presentation. Over to you, Chris. Thank you.
Thank you, Gugu. I'm Chris Chow. I'm actually trained as a mining engineer, and what I'd like to share with you today is some of the work that we've been doing for the last 20 years. Went from mining and then specialized in clean fuel solutions. So as you saw, the title is how do we actually achieve fuel reduction, and through that then achieve our Scope 1 emission reduction today. So if I can share my presentation with you all. Okay, can you see the presentation?
We can see the presentation, yes, Chris.
Okay, all right. Okay, as you know, the hottest subject at the moment within the mining industry is about climate change. Everyone's talking about net zero. And what you see on the slide is a very recent climate change position statement by the International Council of Mining Metallurgy, where most of the big mining houses CEO have committed themselves and their organization into net zero by 2050. So we're talking in the next 30 years time, where, and if you look over here, it actually sets Scope 1 and Scope 2 target and lay out, a clear plan how to get there. And also, most of the mining houses are now actually reporting their emission and their targets and their achievement. What I'd like to show you today is how we can actually get there a little bit sooner. We won't get to net zero, but we will reduce the Scope 1 and Scope 2. Now, if we look at the journey to net zero, and there's a lot of initiatives already taking place. You will know trolley assist, obviously running on an electric motor is faster, you're not burning diesel. And there are electric drills, electric shovels, and I'm sure you've all heard Mohalakwena, I think this year or next year, will start testing hydrogen fuel cells. I know they've already built the refueling station. So we shall see how practical it is. Now, as I said, I've done a lot of fuel projects, and I sit on a lot of fuel bay over the last couple of years. And one of the problems that I see is when a truck comes to refuel, typically the refueling nozzle is covered in mud. So it has to be cleaned off. Now, I don't know how that would affect the hydrogen fuel cell if we start pumping hydrogen at very high pressure into the fuel cell, but we shall see. And there's also solar. So all these technologies are going to come and they will mature, and I'm sure some of them will then be adopted. But the question still is, if you're running a diesel fleet, which I'm sure most of you are, so what can you do now to reduce your Scope 1 emission? And the only way to do that is you've got to actually use your fuel more efficiently. Now, I do talk to a lot of mines, and my first question to them is, do you plan to mine more next year? And most of them do. And if you are going to mine more by nature, you are actually going to burn more diesel. And therefore, your Scope 1 actually going to increase. So there's a thought. So how do you then reduce your Scope 1? Now, and these are now straight come from the internet. So what are the industry players are saying? Now, this is a fuel company. It was published last year in October. And it says, cleaner fuel, improve fuel economy. Now, we all know cleaner is better. Now it's a matter of how do we define that, and how clean can we actually get our system into what we call nozzle to your machines. And here we have two projects published by two significant mining houses. On the left is Anglo. And if you look at it, these projects started running 2015. So 6 years ago, Anglo already said when they start cleaning up their hydrocarbon, and we're now talking ISO standard, if we clean up our fuel, they saw a 3 to 7% improvement or reduction in fuel consumption. And then they said it linked directly to their reduction in scope 1 and scope 2. And on the right is Anglo Gold Ashanti. And they too see a significant reduction in fuel consumption. So now we know cleaner fuel burns better. And that's because we are not gumming up the injectors, the fuel atomized properly, and therefore, we actually see a reduction in burn rate. And I've seen that in all the projects that we ran. And most of the mine use that as an initiative to reduce costs. In the older days, people weren't that keen, weren't that excited about emission, but now we are. So what are these projects? I call them legacy projects. What are they typically aimed at? When I say current and old, fuel management projects typically target what we call 18, 16, 13, or slightly better. And the primary reason for this code is because of the OEM. All your OEM now establish or publish a fuel spec. So not only do you have to satisfy your typical viscosity, density type of fuel spec, they've now added an 18, 16, 13. And that's primarily to do with the new common rail engine. The tolerance on the new engines are extremely low. So we're talking an injector's tolerance of 1 micron. And what they then want you to do as the owner of the machine is to present a machine with minimum or better, code 18, 16, 13. And then the on filtration will take it further down to what we now call injectors ready. And if you look, there are many ways of doing that. On the far left, there's mini pour. So you can actually pull a fuel sample, and you can see this one is pretty dark, through a vacuum onto a mini pour, and then you examine the mini pour under a microscope, and then you can cross-reference that to some pictures, and that gives you a ISO standard. And then on the other slides, you can use laser fine type technology. And again, that's comparing pictures and shapes. And more recently, you will now use laser particle analyzers. And you can see on this one, I think it's 2008. This is actually the first laser particle we actually implemented in Ghana with one of the major mining houses. Now, that said, the problem with bottle sampling is you're taking one bottle, typically one sample per day. And I've still got clients that actually working on the clear and bright. So if you take a sample and it looks clear and bright, then it's okay. Well, the problem with ISO code and clear and bright is our eye can't see below, I think, 100 micron. And when we start looking at the ISO code, the first code is on 4 micron. And then the third code is on 4, 6, and 14 micron. So our eyes actually can't see the dirt, whereas the laser can. And if you're taking one sample a day, if you don't have anything, it's good. Any sampling is good. And if you have the device, the more sampling you do is actually even better. And then when we start doing continuous sampling, what we see is this. So this is actually now sampling non-stop. And we put an analyzer and we can sample typically 9,000 samples a day. And what you suddenly realize is you're going to get peak and troughs even within a refueling cycle or dispensing cycle. So depending on where and when you take the sample, you might have a different cleanliness level. And also with bottle sampling, your limitation is actually the bottle. Now what you see here, this is a certified clean bottle. but it's only certified clean, if I'm right, to about code 15. They're very expensive. It's about 500 Rand a bottle, and you're not supposed to reuse them. So if you're going to use those bottles, you're going to, cost you a lot of money. So let's look at continuous sampling and how that can assist. Now, we're calling it ultra clean diesel, and I'll define that later. Okay. When you want to dispense ultra clean diesel, the first thing we have to step away with is, instead of treating diesel as a commodity, which most might do, because it's actually controlled by a warehouse. It's a warehouse function because we buy so much of it, and we also want to buy as cheap as possible, and most people see it as in and out, and a lot of mines also do what we call consignment stock, and therefore, and that takes away the theft and shrinkage issue. But we still have to look at it as a critical component, because if we put dirty fuel into our fleet, it will end up affecting the performance of your fleet. And now let's look at what ultra clean diesel is. Now, as I said, the legacy projects run their fuel cleanliness at 18, 16, 13 to satisfy really the OEM, so they don't fall foul in terms of a warranty issue. But we then ask the question and say, well, why don't we drive it all the way down to common rail injectors ready? And what is the net effect of that? And to do that, you now need condition monitoring. And as I said, when you do condition monitoring, we're going to generate a lot of data. Each sensor, as I said, pick up 9,000 odd records. And when we have 10 of those running around, we're going to have a lot of data. And then it's a matter of understanding what the data is telling you. So why treat it as a critical component, first of all? And let's start with, what is the fuel quality coming into site? Now, I have had discussion with various GM, and they said, we don't care. We expect to buy from a reputable supplier, so therefore the quality of the product must be clean. Well, if you don't measure, you don't know. So when we start putting analyzer at offload, we can now measure per compartment, per tanker, what is coming in. And why is that important? The reason for that is we can actually equate the cleanliness level back into dirt. And that's what it is. The cleaner it is, the less dirt it is. Now, if we use a mine that consumes an example of 8 million liters a month, and if the incoming cleanliness is code 21, so 3 codes off what the OEM required, that will generate around 63 kilograms of dirt. Okay, that's quite a lot of dirt. And at some point, either yourself or the fuel company, it doesn't really matter, has to pay to remove that dirt before you present it to the injectors. And if you don't, it will then damage your engine, it will affect your plane maintenance, and which at the end of the day is downtime and loss of productivity. Now, if we look at what happened if we lower the ISO cleanliness to code 17, that actually equates to an incoming dirt of about 4 kilograms. So it's a significant difference, and in terms of handling, and that's why we want to assist in trying to get the cleanest possible fuel into the system to start off with. I know of probably 2 companies, 2 mining houses that actually now contractually bound their supplier to supply this type of cleanliness, and the reason for that. As I said, when you start putting an analyzer there, and we can actually start monitoring, this is 2 dispensing from 2 tankers, and you can actually see on an average basis what is the cleanliness level. From this particular slide, we're actually bringing in code 15. And the little spikes that you see are actually when we start changing from compartment to compartment. And we count all of those. So we actually need to look at the whole, dispensing dump from the tanker, and then we can work out a cleanliness level per tanker. And you can now start benchmarking if you are multi-supplier, which supplier actually giving you a cleaner product. Now, so that's the starting point. We then have to look at the entire value chain from receiving product and to eventually putting product into your fleet. And there's also an element of managing your tanks, your bulk tank, because as you know, there's a breather. So as the fuel level go up and down, we're actually sucking dust or air into or out, or pushing air out of the tanks. And depending on your environment, depending on the season, you may be bringing dirt into your system. And then do you have floating suctions? Are you pumping your product at the bottom of the tank? That all influence that. But one of the biggest problems that we've seen is actually water. Now, I've been to a lot of fuel farm, and every time I go there, the first thing we normally do is we actually open up the water drain. We actually pull product out to see how much contamination is sitting at the bottom. Because as you pump product, as I said, in and out of the tank, you stir up your tank, and if you have too much sediment and water at the bottom, that can end up at your nozzle end. And also what we find is because people are very scared of theft, most of these water drains are being locked up, so which means the site actually never drained. And this is an example of a drain, and what you see is black sludge, and that foam is all bacteria layer sitting on top. So that has to be managed on all sites. And then you will have bulk filtration, which we monitored as well. So now we monitored every single drop of product that are being dispensed into your HME fleet. And that is reconciled to your, if you have a fuel management system, so that we actually look at the daily data, and we can actually then work out which period of time is the refueling, is the actual authorized refueling, and then we can then work out the actual ISO code being dispensed into the fleet. And the last thing that we have done is we realized on an open cast mine, probably about up to 30% of your fuel usage are actually dispensed into the in-pit equipment. And so we designed our solution to be extremely rugged, so that we can actually then capture the in-pit refueling cleanliness as well. And this is an example of just a Bowser with the equipment sitting there, and we're monitoring post-filtration. So is the cleanliness of the fuel after filtration at all time, what's going into the fleet. Okay, and those are just two more slides of the type of data coming from the fuel farm and from the mobile equipment. And if you look at the cleanliness level, they're actually very, very low, very good, because that's the target on this particular mine. We aim to dispense between code 12 and code 13. Okay. What we see here is a slide that we've been monitoring the whole fleet. As I said, we monitored on a daily basis. So from the daily, we can generate weekly report, we can generate monthly report, quarterly reports, etc. And this is just an example of a hyperclass. So this is a 400-ton truck, and it's a fleet of them. So this is many trucks behind it, and we have additional slides for the smaller trucks. So from your 200, 250 to your 300. So this mine runs about 40-odd haul truck, but they all, the profile look exactly the same. So what this is telling you is the red line is just the tracking of the daily cleanliness, the ISO cleanliness, and the blue line is the burn rate captured by fuel management system, which we then correlate. And what you see in the beginning of this exercise, the ISO cleanliness were on the 18, somewhere around there. and we start managing the program and understanding what the capability of the filtration system is about, and then applying the correct filter change protocol, and also challenging the filtration system as well. Is the current filtration system able to allow you to dispense ultra clean diesel? And if the answer is not, then obviously we have to change the filtration design. And like I said earlier on, that also is a factor of how clean is your product coming in, because the cleaner the product coming in, the easier it is to dispense ultra clean diesel, and then couple that with your tank management right across the value chain. So what you see here is after about 3 months, we started seeing a drop in ISO cleanliness, and every time the ISO cleanliness dropped, you see the burn rate drop. And this is repetitive right across on every month and every fleet that we've been working on. So now we can actually quantify by dropping your cleanliness, I am now reducing my fuel burn. And by reducing your fuel burn, I am now emitting less CO2. So the two actually go hand in hand. And if you now look after the 3 months, we are now, our code, instead of using up to 20, we now drop it to 15. And if you look at most of the time, we're actually running somewhere between 11 and 13. Okay. Oops, sorry. So just to show you in an actual site, what this actually is. Now, this is actually a mine. That's their quarterly production. So this is ore and waste. So this is the total BCM coming out. And what you see, is, as I said, is a mine typically increasing production as they mine. And what typically will happen is you either use more fuel because you're mining more, or at minimum, your fuel burn, your consumption would be level, because you'll be maintaining your fuel consumption if you have, trolleys, etc. And what we are seeing here is when we start tracking the liter per 1,000 ton, we are seeing a reduction. So the two graph is, I would say they're not naturally, they should either follow each other, or this one should actually be more or less straight. And what you see here is because we are driving the cleanliness program, we are actually improving the efficiency of the fuel burn. And against a backdrop of a 14% increase in tons, we're actually seeing a 12% drop in liter per 1,000 ton. So really, what is that the key takeaway today in terms of sharing with you what we're doing, how I believe the industry can, as I said today, reduce improve your consumption, is, are you dispensing ultra clean diesel? So, and as I said, ultra clean means, are you dispensing injector ready diesel? This is sitting at code 12 or thereabout. Okay, and if the answer is no, you're not doing that today, then there is a potential to reduce your fuel consumption right now. Now, we've worked out a correlation as well. For every ISO code that you can reduce, there is a corresponding reduction in fuel usage. Okay, and if you do that, and if you're burning your fuel more efficiently, you're using less immediately, you're saving money, first of all. You're also not subjecting your engine to as much wear, so therefore everything just works a little bit better on the engine. And that will then give you your scope 1 emission reduction. And hopefully, I've been able to show you, there is a certain way that we can do right now, managing our fuel cleanliness, and then allowing then the mine to achieve, real scope 1 emission reduction right now. Okay, so that's the presentation. So I'm now going to answer any questions. see there's some chats here. Sorry, Google, is there, can anyone hear me? Is there any questions?
Yeah, we can hear you, Chris. I think the attendees can only be able to post the questions on the chat or on the Q&A tab. They're not going to be able to post them verbally. So for all the attendees, if you have any questions for Chris, please kindly post them on the Q&A tab at the bottom of the screen, or you can just post them on the chat function. Doesn't seem like we have any questions. Chris, I don't know if there's anything maybe that you want to add or comment on.
Not really. If there's no question, either I answer all the question up front. Or look, I mean, it's when I say it's simple, it is, because I think total fuel management is as a concept is not new, but to drive it to the new level, that's actually what's new, and obviously that require new technology behind that. So I did, on the slide, I did put my email and my telephone number. So if anyone needs any further clarification, I'm happy to answer you. One Q&A. Has anybody, sorry, question from Alec. So if I can just read it out. Has anybody done any work on online continuous filtration on a vehicle? Do I type? No, I suppose I can just answer it online.
Yes, you can answer it live. You can answer it live, Chris.
Okay. Alec, we have been asked when we first started our quest with the mine. The aim at that point was to then put inline monitors on every single haul trucks. But we then very quickly realized, it would be a lot of costs, and if we manage to source, i.e. post-filtration on your refuel bay or from your fuel bowser, then we're actually putting on-spec product into the mining fleet. So no, I don't know of anyone doing that. I know Cummins, because we do work with a lot of the OEM. Cummins have developed a platform. Now I don't know how successful that is, because they were going to monitor all kind of things on their engine. And one of that was inline monitoring of the fuel cleanliness. As I said, I don't know how successful or whether they've rolled it out. I know they were monitoring air filters. They were monitoring the differential pressure across the filter banks. And then obviously they could measure temperature and all kinds of things. Hope I answer that. Appreciate that, Eric.
We still do have a bit more time. So delegates, if you've got any other additional questions, you're welcome to post them on the Q&A tab or put them on the chat function.
Cool. If there's no more question, maybe we should end the webinar.
All right. Thank you everyone for joining us. And I think Chris, you did mention that you've got your details on the presentation slides. If delegates want to get hold of you after, maybe they might have questions or comments after the webinar.
Sure.
Let's see this other question.
Sorry, I just saw one question now coming in from Alec. Sorry, let me just read it. In your mind test, was it possible to actually quantify the reduction in scope 1 emission? Yes, Alec. Obviously, well, the answer is actually interesting. Sorry, because at the end of the day, the mine actually used a little bit more diesel because there was an increase in terms of tons being produced. As you could see, there was as I said, 14, if I'm right, a 14% increase in tonnages from Q1 to Q3. But then there was a 12% drop in fuel usage. So I think what's actually going to happen is one actually need to start reporting your emission to your tonnage produced. If we are purely reporting on just liter used, that will actually skew the scope 1 emission. Because if you actually do not have an intervention of any sort, then your fuel usage would have gone up by 14%. Whereas in this case, the fuel usage has gone down by 12%. So I hope I can answer you on that.
All right, Chris, you can just let me know.
Yeah.
After maybe, yeah.
Okay, so I think that's all the question.
So Chris, we will share your details with the delegates that attended in case anyone wants to get in touch with you and ask you any follow-on